Now, I want to mention a few things about Gaussian elimination. Eventually, we're going to put this in octave. And um, one thing that you should observe is that sometimes when we did Gaussian elimination with two equations and two variables, we would perhaps, instead of dividing the first equation, multiplying the first equation by the reciprocal of a11, maybe you would want to do the reciprocal of the second equation, right? So like in here, remember in this little example here, to eliminate x5, 5x1, what we did here was to divide the first equation by 3, which is multiplying by the reciprocal of 3, right? And then multiplying by -5, so this way we can add the two equations and then the coefficient of x1 will be 0. Another way you can do that is to multiply the second equation here. So you multiply the second equation by the reciprocal of 5, and then multiplying by opposite of 3, like that. But then we would multiply the second equation by that coefficient, by this factor, and then add to the first equation and replace the first equation. That's something you can certainly do, but then you will eliminate 3x1, okay? So you would eliminate 3x1, not the 5x1. And then you can switch the equations, right? If you eliminate 3x1, you can switch the equations, and then you get x1 eliminated in the second equation. But that's also possible, but that's not a very effective process, because you want to implement a systematic way, a systematic process of doing the Gaussian elimination. So that's what we do here. So because of that, these coefficients here, a1, and then after we eliminate, so a1 is called, it has a special name, it's called a pivot, okay? It's the pivot because we use that to, divide by the reciprocal, multiply by the reciprocal of a11 and add to all the other equations below that equation. And then once we eliminate these guys here, then the next pivot would be a22. Well, this a22 at this point is not the same a22 from the original system, because after you multiply these equations and add and keep adding and multiplying, all these coefficients here might change, and they might be different numbers after you do all these operations. Okay, so the new a22, okay, whatever that is at that, after we eliminate these three guys here, whatever that is, that's called a pivot again, right? And that's used here. See here, that's used here to eliminate the other two terms from the other terms from the equation 3 and 4. Okay, and then same thing here, a33 is also called the pivot. To eliminate, it's used to eliminate this guy here. Now you notice that if those pivots, they're small numbers, right? If a11 is, for example, 0.0003, that's a small number, then you're dividing the whole first equation by a very small number, which makes the first equation, the coefficients, big numbers, right? When you divide by a very tiny number, you create a big number. And if you think about that, that can lead to round-off errors, right? Especially if you have a finite precision, which all computers do have finite precision, right? But after you do a lot of those calculations, you're gonna introduce round-off errors, and then your final solution will not be accurate. So that's one thing we will have to think about, and that's the next section that we're going to study later, It's called Gaussian elimination with pivoting. In other words, you try to avoid small pivots. So before we do the Gaussian elimination, maybe we're going to switch a few equations to put big numbers as pivots instead of small numbers. So that's something we're going to do. But anyway, these are called pivots, and so just to have that in mind. Okay.